Afternoon, guys. Good afternoon.
Afternoon.
I just can't find my gloves.
Afternoon, guys.
Hold on a second.
Good afternoon.
Okay, I found my gloves. My glove disappeared. What did I do with it? Hold on a second. Okay, found it. All right. All right, can you see the screen and hear me clearly?
Yeah.
All right, so only the two of you are here, but that's all right. The sessions are recorded, so others can get the recording later. All right. Hold on a second. Hold on a second. One second. One second. All right. All right, so the first thing I want to do is just work through the classwork quickly. I think most persons have it and understand it now, but let me just give my own take on it. And then I want us to do some past papers. I'm just gonna do some past papers for practice because I'm coming off this topic from tomorrow. All right, so that is the plan, to start a new topic. But not tomorrow, next class, which is Tuesday. I'm gonna start in the Sunday program until a couple of weeks. Maybe next week or the week after. We start the Sunday program. All right. So this first question right here, this one. Gives us a root. It says one root of this equation, where k is a constant, is 1. So since that root is 1, it means that we can fit that value of 1 for the x. Is basically an x value that satisfies the equation. So we can fit that value in it. So it means that on the equation x cubed plus kx plus 11 equals 0, x equals 1 is a root, x is equal to 1, which implies that x minus 1 is a factor. Okay, remember, if you know a root, you also know the factor. All right, so we want to find the value of k. So 1 works on the equation, so we can substitute 1 inside the equation. All right, so that's what we're going to do. So we're going to say that implies that 1 cubed plus k times 1 plus 11 is equal to 0. This and this really is 12, and we've transposed the 12, we're going to get k equals negative 12. And that's the answer for k, which is what they wanted us to do first, find the value of k. It says, hence find the other two roots. Hence find the other two roots of the equation. So basically, I want to solve the equation. We already know one factor, so we can use that factor to simplify the equation down, factorize it down, and then we can go through and find the roots. And this statement here is like a hint to me to say it cannot be the quadratic part of it, because this is going to be the linear factor, x minus 1. The quadratic part of this equation, we won't be able to factorize it. And so they're telling us how we should give the answer. We have to give the answer in standard form, in exact form, meaning no decimal point or anything like that, no decimals, no correcting, no rounding off. All right, so the equation becomes x cubed minus 12x plus 11 equals 0. We want to simplify it down, want to simplify this expression down, want to factorize it down in order to solve the cubic. So we're going to divide it by the factor that we have, x minus 1. And so we're running our long division on it. X minus 1 into x cubed. There is no x squared term there, so we're going to put in as 0x squared. Want to have descending powers of x minus 12x plus 11. You divide this first value by this first value as always. Divide those. We're going to end up getting an x squared. Then it's x squared times these gives us x cubed minus x squared. And then we're subtracting. So it is a negative minus x squared gives us a positive x squared plus 0. Just gives us x squared. And then these come back down unchanged, but they're not subtracting anything. So it's minus 12x plus 11. Then it's this divided by that, which gives us x. That's a plus x. Then it is the x times these. That gives us x squared minus x. We're subtracting again. So this minus makes us a plus x, or makes us x. So it's x minus 12x is minus 11x plus the 11. This 11 comes back down here. All right. And then we're dividing this now by the x to get minus 11 up here. Then it's minus 11 times these. It's going to give us minus 11x. Plus 11, so we're subtracting the same thing, and so the remainder is 0. So the equation, this equation becomes the product of this and that. That expression becomes the product of those two. So we end up having x minus 1 times x squared plus x minus 11 equals 0. But this cannot be factorized any further. It is irreducible. And so we're going to go and say this part equals 0, which is giving us the first root that we had. I can just write x equals 1. But then now this now will also be equal to 0. So that equals 1, or x squared plus x minus 11 equals 0. So it's like we get a quadratic equation to solve that cannot be solved by factorizing. We use a quadratic formula, which then means that we're going to get x equals minus b. The b is a 1 right here. Plus or minus the square root of the b squared, which is 1 squared, minus 4 times a. The a is 1 in front here. Times c. The c is negative 11. All over 2 times a. The a is a 1 in front, the x squared there. And so in the exact form, this is x equals minus 1 plus or minus the square root. This up here becomes, this is 44, and 1 makes 45. And you're dividing that by 2. So those are the other two roots. X equals minus 1 plus root 45 over 2. Or the other one is x equals minus 1 minus root 45 over 2. And these are the other two roots, other two roots of the equation. All right, so everybody good with that. But all right, but okay.
Yes, sir.
All right, so I don't see why this question should pose a problem really. Because this is the question that they typically set for polynomials. That's the question they typically set, you know. That's the form of a polynomial question that is mostly set. One way they give you a factor, and then they give you a divisor that is leading to a remainder for you to get two equations. Most of the questions are like that. I get two simultaneous equations to solve simultaneously because you have two unknowns. So this question really should be easy for everybody. They said the same question on pure maths and on odd maths. This is the typical polynomial question from back in the day. Most polynomial questions on exam paper are set out exactly like this one. Just the values are different. All right? It's not completely easy. So anybody who can do this and have a problem, it means that you're not practicing enough. You're not seeing the papers, you're not seeing past papers, you're not practicing, because most questions on polynomials are like this. All right. So they give us f of x as a function equals 2x cubed minus px squared plus qx minus 10. And it says x minus 1, it is divisible by x minus 1, means that x minus 1 is a factor. So x minus 1 as a factor, going to give us one equation, because this means that f of 1 is equal to 0. Means that we'll plug 1 in there for the x, we equate it to 0. That's going to give us one equation. Plug the 1 in there, plug the 1 here, we're going to get 2. Plug the 1 here, it's going to become 1 times minus p, we get minus p. Plug the 1 here, we're going to get plus q. This minus 10 comes back, and that is all equal to 0. Then this and this now makes negative 8. So the expression becomes minus p plus q minus 8 equals 0. This is the first equation we have gotten from the factor. That's using the factor theorem, equation 1. Then the remainder theorem now is in relation to this part. When divided by x plus 1, the remainder is negative 6. Remainder theorem says that f of negative 1 is negative 6. Because the remainder is f of negative 1. When you divide by this, the remainder is f of negative 1. Simple. So the x plus 1, let's write it in blue. The x plus 1 divisor lead to a remainder which is negative 6. What is the remainder equal to? It is equal to f of negative 1. So they're telling us that f of negative 1 is negative 6. So we plug negative 1 in the function here. It is equal to negative 6. Function become equal to negative 6. That is all. That is the remainder. That's the remainder theorem. So we plug the negative 1 in there now. So negative 1 you're going to become negative 1 cube going to become negative 1 times 2 is negative 2. The negative 1 here is going to become a positive 1, and the positive 1 times negative p going to give me minus p. Then the negative 1 here is going to give me negative q. That's right. Right, negative q, yeah. And then now I get back the minus 10. And then it's equal to negative 6. I'm going to simplify this now. So this and this is negative 12. This negative 6 comes over and become positive 6. So they come together on this side. These come together on this side to become negative 6. Negative 6, right? But that's negative 12 plus 6 is negative 6, right? So I'm going to end up having negative p minus q minus 6 equals 0. That's my second equation. And so now solving equation 1 or 2. If I add them, I will eliminate the q. One is a positive q, one is a negative q. So if I add them, add up everything together, q is eliminated. So I'm going to add 1 and 2. I'm going to add the two equations. So minus P and minus P is minus 2P. The plus Q and the minus Q eliminate each other. The minus 8 and the minus 6 is negative 14 equals 0. If I transpose the 40, becomes positive 40 and divide by the negative 2, I get negative 7. So P equals negative 7. And then to get the Q, I can take the negative 7 and I can plug the negative 7 all the way up in this one for the P. Find out what the Q is. Nice and easy. So I can just say, and I'm going to plug it in up there now. Minus a negative 7, that's right here, minus a negative 7, plus Q minus 8 is equal to 0. This minus makes is a plus 7. 7 minus 8 is negative 1. Negative 1 transpose over it to become positive 1. And so Q equals positive 1. That's my values for P and Q. Those are my answers right there. This is one answer. This is the other answer. But okay so far?
Yes, sir.
All right. And then now they want us next to factorize the expression fully. Factorize f of x fully. Factorize it. We already know one factor already. But since we know the P and the Q, we can now write the function. We now know the function. So let's write the function. So for part 2, the function becomes 2x cubed. Remember the P is negative 7 now. And this is minus P. Minus minus becomes a plus. So this becomes a plus 7x squared. I think I write in this too large. This too, let me make it smaller and then carry it on the screen. All right. And then now I'm getting a plus Q x where the Q is 1, right? So that's just a plus x and then minus 10. But I already know that x minus 1 is a factor. So to factorize this down, I just need now to divide by the factor that I have. So I'm going to divide by the x minus 1. I don't want to use the x plus 1 because that's not a factor. I'm trying to factorize it, so I divide it by a factor. So I'm going to factorize it. Divide it out first. That's 2x cubed plus 7x squared plus x minus 10. And this divided by this is 2x squared. And then 2x squared times these give 2x cubed minus 2x squared. Subtract. This minus makes it a plus 2x squared. Plus 2x squared and 7x squared is 9. So I'm going to write 9x squared plus x minus 10. And it's this one divided by that again. So I'm going to get plus 9x. The 9x times these will give 9x squared minus 9x. And we're subtracting again. So this and this makes it a positive 9x. So the positive 9x plus x gives me positive 10x. And then this minus 10 comes back. Minus 10. Then it's this negative 10 divided by the x. That's going to give me plus 10. And then it's 10 times these. Give about the 10x minus 10. When you subtract that, remainder is 0. And then this can be factorized right where it is. Can it? Can that be factorized? Yes. Because 5 times 1 is 5 and 2 times 2 is 4. 5 and 4 makes 9, which is the middle term. So this factorizes out into, let's factorize it right here. 2x and x are the only factors of this. I need to put the 2 with a 2 over here to get 4. So I put 2 with a 2 and a 5 right here. Signs are the same, everything positive. Everything positive. So I'm going to put a plus right here and a plus right there. So those are my factors. These are my factors. Those 3 things in red are my factors. I'm going to write them. All right, I'm going to write them. So my f of x is x minus 1 times 2x plus 5 times x plus 2. That is my factor. It is factorized. And that's it. Factorized fully. Then we come to number 3. But I heard to that one. But okay with number 2. Most polynomial questions are set like number 2. Most of them. Set like number 2. All right. So let me do the third part now. The third question, I should say. So the third question gives us this expression. It says use a factor theorem to find a linear factor and hence factorize it, right? Expressed as 3 linear factors. In other words, factorize it, right? Factorize it. So I'm going to start by saying f of x equals 2x cubed minus 7x squared plus 2x plus 3. All right. So I want to factorize. Let's choose trial and error to find a factor first. I don't think 1 will work. Will 1 work? Because yes, 1 will work. Because if I put x equals 1, it's going to become 2 minus 7 plus 2 plus 3. No, so the minus 1. Let's try the minus 1. We're looking for 1 first. I prefer to try values roughly first, and then when I find a value, I use it. So this will become minus 2. This works. This will become minus 2 minus 7. This will become plus 2. This don't work either. This don't work either. No, this will be minus 2. Minus 2. And then plus 3. So this don't work either. Which value worked? Somebody tell me a value that worked. So I don't have to do it. Somebody who did it before, tell me a value that worked. So I don't have to waste time and work it out. Well, it's factors of 3 or 1. So maybe 3 is the other value to try. So let's try 3. Try 3. Somebody tell me now who did it. Tell me a value that worked.
1.
1 worked?
I think so.
But I said the solution in the group last night. Didn't I?
I used 1.
Yeah,
I used 3.
1 working. I don't know why I didn't get started, but 1 worked. Yeah, 1 worked for true. So if I try 1, then this will become 2 minus, oh, I see the mistake, minus 7 plus 2 plus 3. Yeah, so these add up to 7. So 1 works. And 3 works as well. All right, so let's use that method where we try both values. So let's do that method where we try, because the only factors of 3 right here is 3 and 1, right? Plus or minus 3 and 1, plus or minus 3 and 1. So if we try 1, then f of 1 will become 2 minus 7 plus 2 plus 3 is equal to 0. So that works. And if we try 3, so you're saying positive 3 works as well. Okay.
It wasn't me who used 3.
All right, f of 3. Yeah, but all right, but if
Yeah,
one
I
of your,
used 3.
if one of your factor come out to be x minus 3, then you know that 3 will work. So anyway, let's go. So this is 3 cubed is 27. 27 times 2 is 54. Minus 7 times 9. 7 times 9 is how much? What is 7 times 9? What is 7 times 9? 63. Don't it? And then 3 right here makes that a 6. And then we're adding back a 9. Adding back a 3, sorry. That gives us 0. That don't give us 0. It's a wrong value. Boom, 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 boom. 2x.
It does give 0.
Equals 0. So that works. All right. So that works. So since we know the two factors, look how we can do it now. So f of x, we can start out and say, since we know that these are factors, that works. So we can say this means that x minus 1 is a factor. It's a factor. And this works. And therefore, x minus 3 also is a factor. Let's try to get through this question so we can do some past papers. So we're going to get x minus 1 times x minus 3. Then the third factor now, we don't have to actually calculate it. We can just observe and work it out. So what it is that this first value here is the product of the 3 first values here, here, and here. So if these two already multiplied to be x squared, and you need 2x squared, 2x cubed, then this value has to be a 2x by observation. So this value has to be a 2x. And then this last value, the 3, is a product of this, this, and this. And if these two are already multiplied to give us a positive 3, and you want a positive 3, they must be multiplying by a positive 1 right here. So that last value must be a positive 1. Must be a positive 1. So this is a positive 1. So those are the 3 factors. Hold on a second, guys. I'm calling me at work. Just give me a second. Sorry about that, guys. Right. So that is basically it, factorized. And then now this part is simply asking us to form q of x, which is f of x plus 1. Right? So if this is f of x and they want it in factorized, express q of x as a product of 3 linear factors. So we're not going to substitute it in this one. Right? Don't make any sense. We are going to substitute in the factored one, the one that is already factorized. So if that is f of x, and now we want f of x plus 1, f of, instead of x, now we want x plus 1. Wherever x is inside here, we just need to replace with x plus 1. That is all. Right? Because we're replacing this x with x plus 1. So we just need to replace this with x plus 1, this with x plus 1, and this with x plus 1. That's all we have to do. And we'll have the function. So we're going to put the x plus 1 there for that x. And then subtract this one. And then put the x plus 1 for that x. And then subtract this 3. And and then it is 2. I want to replace this x with x plus 1 right here, and then plus back that one. And then just some algebra to work out, right? It becomes equal to, this is plus 1 and minus 1 eliminate each other. So this bracket becomes x. This becomes x, and these become negative 2. So we get x minus 2. Then this now becomes 2x. 2 times x is 2x. Then 2 times 1 is 2. 2 and 1 is 3. It becomes 2x plus 3. And that is it. That is your q of x. F of x plus 1 is q of x. And that is our answer right there. All right, nice and easy. All right, we're gonna do some past papers now. Just for practice. We're gonna start with some pure maths papers. I'm gonna say that they're really very easy. Pure maths, past papers, paper 2. I think we did the 2023 one already. I think so. All right, so let's jump to 2022. And we're looking for any polynomials that's on it. All right. Let's see. Let us see. Usually question 1, part of question 1, or question 2. All right, so we did this one. Yeah, we did this one already, you know, this one. I think we read a polynomial, it's more algebra, this one. But we did it. We did it 2022. I forgot we did that one. And then it goes into some logs. All right, so that one was done. Let's do 2022 then. 2021, sorry. 2021. Let's look for the polynomial on 2021. Let's see. 2021. There you go. There's a typical question. Did we do this one? I don't even know. They all look alike, so maybe we did it, maybe we didn't. I don't know. But you see, it's the same thing. I think we did this one, you know. I think we did this one because we said in the class, yeah, I remember doing this one. We did this one in the class actually. We said this is divisible by this, so that's f of a half equals 0. F of a half equals 0. And then now when you divide by this, you get in -5. So this one is going to give us another equation, f of -2 equals -5. And you're going to get 2 equations. I'm going to get one equation from this and one equation from that. And I think we did do this question. Yeah, I remember getting the 1/8 and multiplying by the 8 and stuff, right? So we did do this question. So I'm not going to do it. I want to do questions that we have not done. We did this question before. And those classes are recorded. So you can go back and find those recordings. Look at the recording. I remember even the 7 marks down here. I remember it. So we'll do this one already. So let's look at 2019. 2019. Let's see if we did this 2019 as well. Let's see. What's on this one? Right. So spoke about this one, but we didn't actually do it. So we can do it now. All right. So this is more of the same thing, guys. So I tell you, it's the most common way to solve a question for these polynomial questions. It tells you this function, f of x, it is divisible by x minus 3, meaning x minus 3 is a factor, and it leaves a remainder of -27 when divided by x minus 6. Right? So this is a factor, and this is a divisor that leads to a remainder of -27. So it's the same, more of the same. 2 unknowns, you're gonna get 2 equations. And the beauty about this question, I'll tell you what the value is supposed to be. A is 3 and B is -63. So let's just do it now. All right, let's just do it. All right. So what they're basically saying is that x minus 3 is a factor. Therefore, f of 3 is equal to 0 using the factor theorem. So I plug 3 inside here and equate to the 0. 3 right here makes that 9, so that becomes 9a. 3 right here makes that 36, because 12 times 3 is 36. Plus back this b, that is equal to 0. That's our first equation. Then they said that when you divide by this, the remainder is 27, negative 27. What does that mean? What they're saying is that x plus 6 divisor lead to a remainder which is equal to negative 27. What is that remainder? The remainder is f of negative 6. So f of negative 6 is equal to negative 27. That's going to give us our second equation. Let's put it up here. Right? That's what this means. F of negative 6 is that. So we'll put the negative 6 right here. We're going to get a positive 36. We're going to get 36a. And we plug the negative 6 right here. You're going to get 12 times 6. 12 times 6 is how much? What is 12 times 6? And we're going to get worker plus b equals negative 27. What are good at that?
Yes, sir.
All right. So basically solving those two equations now. Equation 1 and 2. And since this is a b and this is a b, we can solve by subtracting the two equations. So we can do equation 2, because this have a larger a. We can do equation 2 minus equation 1. Let's do it that way. Equation 2 minus equation 1. All right, let's look for the like terms and subtract them now. So 36 minus 9 is how much? What is 36 minus 9? We're subtracting. Come on, you guys have to be here as well. (27a) and then minus 72 minus 36. So what am I getting for that? What am I getting for that? Minus 72 and then subtract 36. What am I getting? Minus 108. Nobody talking. Now move forward unless people start talking now. Then b minus b is eliminated. Negative 27 minus 0 leaves me negative 27. When I'm solving for the a, I can carry this 108 over there and then divide by the 27. So a is equal to 108 minus 27 divided by 27. And they said that is supposed to be equal to 3. Is that correct?
Yes, sir.
That's it? It works?
All
right, so now that the a equals 3, we can take the 3 and substitute for the a right here in this equation. So we can just say and. We substitute, we're going to get 9 times 3 plus 36 plus b equals 0. This is 27 and 36. 27 and 36 is what?
63. 63.
You go over there and subtract, give me negative 63. So b equals negative 63. So each of them were shown. So this was shown to be true. And this was shown to be true. Because this was a prove it question. That's part A. What part B? Part 2 say. Part 2 say, hence determine the factors now. We have to factorize it now. So now that we know the A and the B, we need to factorize the expression. Let's write it out up here. Let's write it out up here and then copy it down. So the f of x becomes, let's write it here. So the f of x becomes, the a is at 3, that becomes 3x squared plus 12x, and then this is now negative 63. Let's shift it over. That's what we're factorizing. That's what we're factorizing. So let me copy it down and factorize it. It's a quadratic, you know, very easy. All right, so the first factor I'm seeing is a 3. First factor I'm seeing is a number 3. All right, determine the factors. And the first factor is 3. So I'm going to get 3 into x squared, come again, x squared plus 4x minus 13. This right? It's not work out. One factor was what again? What was a factor again? One factor was x minus 3. This can't be right. This is not correct because the a equals 3 and the b equals negative 63. Oh, and a 13, you know, my mistake. I took it as 69. 63 may a factor, I might get 21. Yeah. It's a 63, may get 21, not 63. I get 21 right here. So wow, what a mistake. This is 21. Divide this by 3, you get 21. And let's see now. 3 bracket, 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 bracket. So x and x. Number one was minus 3. So it's 3 plus 3. Yeah, x minus 3. So it's x minus 3 and x plus 7. Yeah, correct. That is it. So those are the factors. So you have to factorize the 3 right there. Okay, if you got them to factorize it, determine the factors, you can write x minus 3 and leave 3x minus 21. You know? Got them to factors, you have to always factorize it as part on and that can be factorized again. So that's the correct answer for your factors. Factorize the 3, that quadratic. All right, I think that finishes that question. 2019. Let's look at 2018. 2018. If there's any polynomials and looking for something interesting. For some easy stuff. Almost the same question every year. Almost the same question. All right, look at this one. All right, this one might be a little bit different. So this question says, given that, all right, this one look a little bit different. Not your normal run of the mill. This one says, given that this thing is equal to this thing, right? They want us to determine the value for A, B, and C. What do you think we can approach this, guys? What do you think? What do you think we can approach this one? An idea? Okay, approach this one. How much marks for it? So much marks for this. And 2 pages they're giving now. Wow. 7 marks, 2 pages. What do you think, guys? Look at it. They tell us that this expression is equivalent to this expression. In other words, this is a factorized format of this. That's what it is. Or put another way, if you expand this, you're gonna get that. What do you think you can approach this? Somebody, quickly? Any idea how we can approach it? We want to find the value for A, the value for B, and the value for C. Anybody? Nobody? All right, there's only 2 of you here anyway. All right, so now none of you are prepared to go. All right, the first thing you have to remember, guys, is that this first value times this first value times this first value is equal to this first value. That's going to give you one equation. Another thing you have to realize is that this second value times this second value times this second value give you this last value. That's going to give you an A. You're going to know your A from that, you know. And then the third thing you have to realize is that this is a factor. That's a factor, you know. That's a factor of this expression. And if it's a factor, it means that f of one of this is going to be equal to 0. So that's how you can do it. Another way to do it is to expand this out, but that's a lot of work, and then equate the coefficients. Expand that out and equate the coefficient. But I think the shortcut method is a better way. So we're going to look at this times this times this equals that. That's the first thing we're going to say. So we're going to say 2x times x times bx equals cx cubed. Are really the coefficient. I didn't need to put the x values on the coefficients. So let's write it. Let's look at it that way. The coefficient of x cubed. Coefficient of x cubed. Coefficient of x cubed. This times this times this equals that. So it's 2 times 1 times b equals c. So it means that 2b equals c. That's one expression. And then the constant term. Constant term is a times negative 1 times 1 equals negative 10. So you know your a already. So see, it becomes a times negative 1 times 1 equals negative 10. So it means that a equals 10. So you know the a already. So now you need to establish another relationship between b and c, because you have a relationship between b and c now. You know. So to find the b and the c, you need another relationship with b and c. But you have to also realize that this is a factor of this expression. Right? So let's say that using the factor theorem, right? So when I say x minus 1 is a factor. So since this is a factor, it means that if we call this function, if we call this f of x, it means that f of 1 is equal to 0. So when I plug 1 in there, remember, if I plug 1 in here, so you know, this is going to work out to be 0 now. So similarly, if I plug 1 in here, it's going to equal to 0. But I'm not get that. Yeah, right. 1 I put in there. Good. So if I plug the 1 in here, I'm going to get c. Plug the 1 in here, I'm going to get 10. Plug the 1 in here, I'm going to get minus 2. And then this minus 10 comes back unchanged. And that's equal to 0. So it means that c equals 2. And then if c equals 2 right here, so now, you can know that b equals 1. Right? So you can say c equals 2 and 2b equals c, which implies that 2b equals 2, which implies that b equals 1. And those are the answers quick and fast. So a complicated question is actually very easy. Those are your answers. But recognizing that this is a factor helps a lot. That x minus 1 is a factor. So if x minus 1 is a factor, then f of 1 equals 0. Also, knowing that the product of the 3 first values give you this, and the product of the 3 second values give you that, also helps to reduce it. And so that's what we did. Understand that, guys? They give a lot of space, but there are other ways to do it, other more complicated ways to do it, but this is the simple way. A lot of persons maybe will approach it by trying to expand out all of this. Expand it all out. And after expand it out, they start to compare the values with this one to get the answers. But that is far more work than what I just did. Far more work than what I just did. This is by far the easy way to do it. Understand that, Kai?
Yes.
Shade, understand that?
Yes, sir.
All right. So sometimes the set questions are a little bit different that you have to use your knowledge, some advanced knowledge. Not even advanced knowledge, but not the straight laced question. It's like you have to apply your knowledge then. Let's put it that way. All right. So look careful what I did. Said the product of the first three values in the factor form equal the first value in the expanded form. The product of the second values in the factor form equal the last value in the expanded form. And then this was the only factor that we knew for a fact. We knew that factor, we knew the values on that factor. Since x minus 1 is a factor of this, it means that f of 1 equals 0. And that allowed us to find the three unknowns. So because there were three unknowns, C, A, and B, it's three things we have to do. 1, 2, 3. There are two unknowns, they need two things. That's how it is normally. All right, that's how it is normally. All right, three unknowns, you need three equations. All right, but that is it. I don't think there's anything else for polynomials on this paper, 2018. This is love. Let's look at 2017. 2017. All right, this is a typical polynomial question. This one. You see, they give you this cubic function right here. They say this is a factor, and then you have a remainder of 12 when you divide by this. And they're telling you that show that a equals 2 and b equals -12. So this is very similar to the one that we did earlier, just the values are different. Two unknowns, so we need two equations. This is a factor, which means that f of 2, this means that f of 2 equals 0. And then this divisor is giving us a remainder of 12, which means that this means that f of -2 equals the 12. I'm going to get the two equations that way. So let's go. So firstly, f of 2 equals 0 because that's a factor. So I'm going to plug the 2 in there for the x and put it equals 0. So 2 right here is going to give us an 8. So that is 8a. Let's put it over here. 8a. We're going there. And then 2 right here gives us 4. 9 4s is 36. So we get plus 36. And I'll put the 2 right here. 11 2s is 22. So subtracting 22 plus b. And it's all equal to 0. Using the factor theorem. Now 36 minus that is what 14. So this reduces to 8a plus 14 plus b equals 0. That's our first equation. And then this now is going to give us our second equation. Because you have a remainder of 12 when you divide by x plus 2. So f of -2 equals 12 is going to tell us, we're going to plug in the -2 now. So -2 here becomes -8. -2 cubed is -8. So we're going to get -8a. And then -2 right here becomes a +4. And then 9 times 4 is 36 again. So we're going to get plus 36. And then -2 right here makes it -11 times -2 gives me +22. And this b comes back unchanged. And it is all equal to 12. can simplify this by adding these two values on that side. So I get negative 8a plus that becomes 58 plus b. Could subtract the 12 as well, you know. Could subtract the 12 as well and get 46. Let's subtract the 12 and get 46. Let's subtract the 12 and get 46. So I'm going to get plus 46 plus b equals 0. But understand that? Understand that?
Yes, sir.
This 2. And then what happens, because it's a 8 and a minus 8. If I add the two equations, I will eliminate these if I add the two equations. So let's do let's do it that way. So it becomes equation 1 plus equation 2. These will be eliminated. Then this and this gives me what? 60. So I'm going to get 60 and add those values. This and this gives me 60. And this is 2b. B and b is 2b equals 0. So carry over the 60 become minus 60 divided by 2 would be equals negative 30, as they said. See here? Negative 30. And then to get the a now, I can take this negative 30 and drop it inside this equation right there for the b. So I'm going to get, I can say, and 8a plus 14 minus 30 equals 0. So 40 minus 30 is how much? Negative 16. So this is negative 16. Negative 16 over here will become positive 16 divided by 8. So the a equals 16 over 8, which is 2. So those two values are shown. So that's a shown value. And that's another shown value. Right here. That's what the question said to do, show those values. That is it. That's part 1. Let's see if they want us to do in part 2. Part 2 now says, hence solve the equation. Solve the equation. So they put the expression as an equation now and want us to solve it. And we have one factor already. We already have one factor. So let me write out the equation. The a is 2 and the b is negative 30. So the function, the equation that we're solving will become, the a is 2. It will become 2, write it in blue. The equation that we have to solve will become 2x cubed, that's from here, plus 9x squared minus 11x, and then the b is negative 30 minus 30, and that equals 0. That's what we're solving. We're going to divide it out first, as usual. I'm trying to simplify it down. Place it here. This is the equation that we're solving now. We're going to divide it first with the factor that we have, which was x minus 2. So we're going to divide it with x minus 2. Divide by x minus 2. Long division. X minus 2, 2x cubed plus 9x squared minus 11x minus 30. This divided by this is 2x squared. 2x squared times these become 2x cubed minus 4x squared. Subtract. The minus and minus make this a plus. There's a positive 4x squared plus 9x. 4 and 9 is 13x squared minus 11x minus 30. And this one divided by that gives me 13x. And it's 13x times these, giving me 13x squared minus 26x. Subtract. Is correct? That looks all right, you know. This don't look so right. All right, so this is minus minus, giving me a plus. That's plus 26. 26 and 11 is 37. This is not right. This can't be right at all. This cannot be correct. It was minus 30. Yeah, minus 30 at the end. Let me see. I think I make a mistake somewhere. Let me see. It's minus 2. 2x cubed. 2x cubed divided by that. Give me 2x squared. And 2 times that gives me that. Minus that plus 9 and 4 is 13. Oh, 13 times 2 is 26. Isn't it? Hold on, x minus 2 was a factor. I'm going to choose the wrong factor. Let me see. X minus 2 was a factor. So this time say there. Minus 2 minus 11. All right. Not seeing it. X minus 2 divided by 2x. I'm looking for a mistake, guys. It look like I have a mistake there, but I'm not seeing it. Let me see. So it's 2x that, 2 is 4. Minus minus give me a plus right here. 9 and 9, 4 and 9 is 13. Minus 11. Minus 30. Which is minus, yes. And then this divided by this is 13x. 13 times that, give me this one. This one, I should say. 13 times this, give me this. Oh, I see the mistake now. This minus minus means a plus. So it becomes 26 minus 11, right? So minus minus makes it a plus. So it's like a plus 26 minus 11 becomes 15. All right, my mistake. So it becomes a 15x minus 30. I do the right thing all the time. But I was ignoring the minus minus. All right, minus minus becomes a plus 26. 26 minus 11 becomes 15. Good. And then now the 15x divided by this is 15. So we get 15 right here. And then 15 times these give us 15x minus 30. And we subtract that to get in 0. All right, so we are the right thing all the time. And then we can factorize this right where it is. Let me zoom this down. And let's factorize this where it is. Factorize this right where it is. So we can get the other factor. So let's just do it in the red. Let's factorize this guy right here. So factors of the 2x squared can only be 2x and x. And everything positive. So factors of 15 is 5 and 3. 5 and 3. That's 6 and 5, 11 now. Oh, yeah, 10. The other way around. 5 and 3. That's 10 and 3. 10 and 3 is 13. Good. So those are where the values I'll have to go. Plus here and plus there. All right. So these are my 3 factors in the equation. So my equation becomes x minus 2, 2x plus 3, x plus 5 equals 0. This factor giving me 2. This factor giving me negative a third. Negative 2 over 2, sorry. And this factor giving me negative 5. Those are the answers. All right, guys, I kind of stumbled here because I was thinking the wrong thing here, but it's okay. Everything was correct. Oh, still good? Okay with that?
Yep. Yes,
All
sir.
All right, so let's look at 2016. More maths equals better maths. More maths equals better maths. All right, let's look at 2016. See if there's anything else I want to doubt it. And this was a proof by induction. Something we're going to do on a Sunday class. All right, that was 2017. This is 2016. So since all the two of you here, I don't think I'm gonna bother to do any of the advanced ones. The advanced one really very simple and straightforward and very easy. So I'll just stick to these. All right, see another one here. Polynomials again. Same sort of stuff they're asking. So nobody having a business getting these wrong. They tell us that this is a factor. So this means that f of -3 equals 0. And then now you have a remainder, and that there is a remainder of 10 when f of x is divided by x plus 1. So basically, x plus 1 gives a remainder of 10, which means that f of -1, a remainder of 10. F of -1 equals 10. So that's one equation, two equations. To find the two unknowns, p and q. This is the same thing all the time. All right? Same thing all the time. Let me summarize it right here for you. All right? So this factor means that f of -3 is 0. That's going to be one equation. This is the remainder that I get from this divisor. There's a different color for those. This is a different color. Blue. Right, so this is a remainder when you divide by this divisor. So it means that f of -1 is equal to the remainder, which is 10. That's going to give you a second equation. Let's do the first one, the red one in red, which is that f of -3 is equal to 0. That's from the factor theorem, first part. So we'll plug -3 in there, we equate it to 0. Simple as that. So plug -3 here, we're going to get -27. -27 times 2 is -54. Plug -3 in here, it's going to become a 9. So we're going to get -9. Plug -3 here, we're going to get -3p plus q equals 0. What is -53 and -54 negative is what? -63 that?
Yes, sir.
That's -63 minus 3p plus q equals 0. All right, so this is your first equation. Let's put the equation in purple. Let's put the box in purple. Then this now is going to give us our second equation, information in blue. That the remainder is 10 when you divide by x plus 1. That statement using the remainder theorem means that f of -1 equals 10. That's going to give us our second equation. Plug the -1 in there for the x and equate it to 10. So when you plug -1 here, it becomes -2, because -1 cubed is negative. -1 cubed is -1, so it becomes -2. Plug -1 here becomes a 1, so we're getting -1. Plug -1 there becomes a -p plus this q, and it is all equal to 10. So this is -3. That -3, I can bring over this -10 and make it -13. So I'm going to get -13 minus p plus q equals 0. That's my second equation. And so I'm now solving those two simultaneously. If I want to get rid of the q, I can subtract the two equations, subtract them. All right, and because I have all that negative in it, I'm going to use this one minus that one. So when I minus this one up here, this becomes a plus and that becomes a plus. Let's go. I'm going to do 2 minus 1. Equation 2 minus equation 1. That's what I'm going to do. Let's work it out in purpose still. So the negative 13 minus a negative 63 becomes negative 13 plus 63. So it's like 63 minus 30, which is 50. That becomes 50. Then like negative p minus a negative 3p. The negative 3p minus negative 3 becomes a positive 3p. So like 3p minus p, which is 2p. So I'm getting 2p. This q wipes out that q and subtract them. R of equals 0. So this implies that p equals negative 25. They gave us answers for this one. Yeah, p equals negative 25. See that? And then the q now, to find the q, we can take this negative 25 and drop it right here for the negative p. It becomes a 25 right there. So we can then say and negative 13 minus a negative 25 for the p plus q equals 0. This becomes 25 minus 30, which is 12. Then the 12 goes over there, become negative 12. So the q equals negative 12. So those were two values shown. This was shown, and this was shown. So the same thing again. That was the part 1. That was the part 1. So the part 2 must be asking us to factorize it or something. Or say solve it. F of x equals 0. So we need to put this expression now equals 0 and solve it. So it's the same thing I keep asking. So when I write the expression up here again, that is equal to 0. So the f of x becomes, let me write it up here. It becomes 2x cubed minus x squared. And then the p we say is negative 25. So that becomes negative 25x. And the q is negative 12. So this plus q is negative 12. 25x. Negative 12 equals 0. So this is what we're solving now. And as a cubic equation, I want to solve it. You solve it by dividing it down and finding the quadratic. Right? We're trying to factorize it down. So we're going to divide it by the factor that we have, which is the x plus 3. Copy it down. Divide it with the x plus 3. Paste it here. I want to divide it down with the x plus 3. Let's write it. Divide by divide by x plus 3 long division into 2x cubed minus x squared minus 25x minus 12. I'm trying to simplify this expression down into factors. This divided by this is 2x squared. Then 2x squared times these gives 2x cubed plus 6x squared. Subtract this and this makes it a negative 6x squared. Negative 6x squared and negative x squared mean negative 7x squared. Then these come back down unchanged. So we get a minus 25x minus 12. Then this now divided by this one gives them a negative 7x. So I'm getting minus 7x. Minus 7x times these give us negative 7x squared and negative 21x. Subtract. Then this minus makes it a plus. So like plus 21 minus 25. 21 minus 25 is negative 4. So negative 4 is minus 12. This divided by this is -4. -4 times d is going to be about the same thing under here, which is a -4x minus 12. Subtract that, remainder 0, because we did divide by a factor. And then can this be factorized right here? Yes, because I know so 2 times 4 is 8, 8 minus 1 is 7. So it's can factorize right here. So we're gonna get bracket, 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 bracket. 2x and x are the only factors of this. I have to put the 2 the 4 to make it 8. And 1 right here. Signs are different, give the greater product the minus sign. The greater product is the far product, 8. Make that negative and put that positive. So these are my 3 factors in red. And I can literally write my solution now, you know. Because if I know the factors, I know my solution. I don't have to waste time and write anything else. From this factor, I'm getting x equals -3. From this factor, I'm getting x equals -half. From this factor, I'm getting x equals 4. So these are the factors of my equation. Therefore, these are the roots of my equation. These are my answers down here. Okay with that? That's 2016. Question done. Okay with that? Hello?
Yeah.
Yes, sir.
All right. Going about an hour and a half. We're gonna do a couple more. We'll just try to finish the pure maths ones. That's 2016. Let's go to 2015 and see. All right. 2015. More maths equals better maths. So more you practice, the more you do, the better. I want you to redo all these questions for me, please. Redo all of them. It don't make sense. They repeat questions on the paper all the time. I don't get them right. Questions that they set the same all the time. You need to make sure that you get those questions right. So you master those. You're going to lose some marks on an exam paper. Let it be on something that they don't set very frequently or something that is new, that appears new. Questions that are set often, you make sure you get them right. All right, so here's another question, but this is not a paper that you write on. Another one, this again. Same thing again. This expression has 2 unknowns again. This factor, which means that f of 5 equals 0, and there's a remainder of 24 divided by x minus 1, which means that f of 1 equals 24. Again, you're gonna get 2 equations, simultaneous equations to solve. All right, so it's the same thing all the time, and then they wanted to factorize it. So because you give this factor, you're gonna divide the expression by it after you find your P and your Q. There's 9 marks for that in this paper, you know, 9 marks, 4 and 5. 9 marks, easy stuff. All right, let's do it. More maths equals better maths. Let's do it. So even when it's easy, you see it's easy, you still do it. You still do it. All right, but you need to practice it so it becomes like second nature to you. You still do it. Even when you know what to do, you still do it. You practice it so that it becomes second nature. Second nature. You master questions that they repeat. You don't lose marks on questions that they keep repeating. It don't make any sense. So you see all the questions that we have done so far in the past papers, majority of them are just as the question 2 that we did on the classwork. Question 2. The typical question. Question 2. So majority of the questions so far are just like the question 2. That's a typical polynomials question. So if you can do the ones that appear a little bit different, you make sure you can do the one that is set often. That travesty if you go in an exam room and you can't do a question that is set often. Don't make any sense. You have to master those questions. And you master them by practicing them a lot So you do them like second nature. You have to practice them a whole lot over and over again. And make sure you exploit and you do all the past paper questions that they have them on. All right. So this one again is f of x equals x cubed plus px squared minus x plus q. Let's say x minus 5 is a factor. So it means that x minus 5 is a factor. So it means that f of 5 equals 0. So 5 right here gives me 125. 5 cubed is 125. 5 right here is 25. So it becomes 25p minus this becomes 5 plus q equals 0. So this and this makes this 120. So you get 120 plus 25p plus q equals 0. That's the first equation. Majority of the polynomials questions are like this. Equation 1. Then second part is that the divisor x minus 1 gives a remainder which is equal to 24. That means that f of 1 equals 24. A remainder is f of 1. They tell you that this 24, so you equate them. So this is going to give us now, we're going to plug 1 in the function, plug in 1 inside here. Easy values. So put in 1 there, we're going to get 1. Put 1 there, you're going to get p. Put 1 here, you're going to get minus 1 plus q. And that is all equal to this 24 right here. So this one wipes out this negative 1. So we end up having p plus q equals 24. That's our second equation. So solving them simultaneously. I can eliminate these q's if I subtract them. So I'm going to do the first equation minus this one. All right. All right. So when I subtract equation 1 minus equation 2, I get 120 minus nothing. Still 120. 120. 25p minus p is 24p. Then q minus q, that is gone. Q is eliminated. Then 0 minus 24 give me negative 24 on the right side. And then this comes over now and become negative 144. So 24p equal negative 144. So the answer for this, I think, is 6. I will divide both sides. 6 that, negative 6. That's correct. So p equals negative 6. And if p equals negative 6, and I put the negative 6 for p right there. Then q equals 30, because the negative 6 can come over here, so I add to the 24. So q equals 30, so I can say and the q equals 30. That is it, that's a p and a q. So I just need to put them in the function that they gave us here now, over here. And follow through to factorize it. So the function becomes f of x for part 2. Function then is f of x equals the x cubed. The p is negative 6, I'm getting negative 6x squared minus x, and the q is 30. X minus 5 is a factor, so I'm going to divide it by x minus 5. I'm trying to factorize it down. X cubed minus 6x squared minus x plus 30. This divided by this is x squared. x squared times these, we get x cubed minus 5x squared. Subtract this minus minus means that plus 5x. So it's 5x minus 6x give me negative 1x squared. Then minus x plus 30. Then this one divided by this gives me negative x. Negative x times these become negative x squared plus 5x. Subtract this minus 5 is minus 5 minus 1 from minus 6x. So again, minus 6x plus this 30 comes back down here. And then now, is this divided by that. So I'm going to get minus 6x plus 30. I need to put up the minus 6. And then these now we subtract them, getting 0. Because that's a factor we divided by. And then we can factorize this where it is. Factorize that where it is right here. It's x and 2 and 3 and minus and plus. So those are my 3 factors. And so I can write my 3 factors now, which is that f of x is x minus 5 is x plus 2 is x minus 3. Same thing again. Same thing again. Let's look at 2014. 2014. Let's see what they asked in 2014. Moving on to a new topic next class, guys. So I have to make sure I master this. I want you to work all these questions over again for me, please. All right, so this is a polynomial here, but they kind of built it in with the binary operations. I'm not gonna bother to do it. I'll do it all the binary operation. Let's look at 2013. Bam, 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 bam. This one here. That's a polynomial again. All right, so let me bring it up over this side. Part D is a polynomial. Both of you okay?
Yes, sir.
Yeah.
Make sure you work the questions over for me, please, when I'm done. Make sure you work them over again for me, please. I'm going to send the video right away, because the video is actually on YouTube. But actually, the video is available right away, so you can just go and look back at the questions, work them, and you have the solution there. So you try to work it for yourself before you look at the solution. Each question. You need to practice and master these things. I'm coming off this topic after today, not coming back on it until we're revising for the exam. So this one tells us that this is a factor. This is a factor of this f of x. Show that p equals 6. So this is a factor. All that means is that f of minus 1 is equal to 0. That's what we're going to do. F of minus 1 equals 0 in this question. So when you plug minus 1 in here, we equate it to 0. So plug minus 1 here, it becomes negative 1. Plug minus 1 here becomes a positive 1. Positive 1 times the negative 9 gives me negative 9. Plug the minus 1 here, I get minus p plus 16 equals 0. That's 16 minus 10. That's minus p plus 6 equals 0. Take the minus p over here, make it the subject. We get p equals 6. That's what they said. P equals 6. So i.e. p equals 6. So p equals 6. Then I want us to factorize it completely. And divide by that factor that we have. Same thing again. Same thing again. We're going to divide. The p is 6. So the p is 6. We're going to be dividing x plus 1 into x cubed minus 9x squared. The p right here says 6 now, so it's going to become plus 6x plus 16. And this divided by this is just x squared. It's x squared times these, giving us x cubed plus x. Subtract. This is minus x and minus 9x. This is a square. Sorry, this is a square. So I'm getting minus 10x squared plus 6x plus 16. And this divided by that is negative 10x. Negative 10x times these give negative 10x squared minus 10x. Subtract. This minus makes that plus 10x. Plus 10x and plus 6x is plus 16x. So I have 16x plus 16. This divided by that is 16. We get plus 16. 16 times these becomes 16x plus 16. And so when you subtract that, I mean that's 0. Then we can factorize this where it is. Factorize that where it is, which then is 8, and 8 times 2 is 10. So we get x and 2 and 8 minus, both of them minus. And that's the third factor. So if we were to factorize it now, we would get that f of x is the x plus 1 and the x minus 2 and the x minus 8. Those are the 3 factors. And then say now, hence solve this equals 0. So that's very easy. Part 3. If you solve an f of x equals 0, and these are your factors, then you automatically know the roots. So from this factor, the x is negative 1. From this factor, the x is 2. From this factor, the x is 8. And that's it. Any questions on that?
Yes, sir. They're kind of the same thing, just different values.
All right. I'm happy that you saw that. I'm happy that you saw that. Look on 2012, I never called it a day. I think 2012 was a little bit different. So I think we just catch on all this. Let me see. Same thing, different values. Same thing, different values. All right. Teacher again. Same thing, different values. Do I need to do this one or we can call it a day? This is divisible by that. That means that f of 1 is equal to 0. And as a remainder of negative 6 and divided by x plus 1. This divisor means that the remainder is f of negative 1 and it is equal to negative 6. So you plug the 1 in this and put it equal 0. You plug the negative 1 in this, same thing, but make it equal negative 6. So you get 2 equations to solve. One equation from this, another equation from that, to solve them simultaneously. All All right. So they want to find the P and the Q, then they want to factorize it. So it means they're going to divide by the factor. Divide by the factor. You won't divide by this, that's not a factor. Always divide by the factor. They're trying to factorize the expression. So that's it. I'm not going to bother to do this last one. 2012. I don't think I have any other pass before on this document. This device. It went down to 2012. All right. I'm going to leave that one for you. 2012 one. Let me leave that one for you. It's basically more of the same, as you can see. All right, guys. So instead of 2 hours, basically I did an hour and a half. Just over an hour and a half. All right. Good, okay?
Yep.
Yes,
All right.
sir.
I'm going to send the video right away because it's a YouTube video. I have to save my space on the Zoom because I have limited space on the Zoom on my Zoom account. So try to save some space on the Zoom. So I put it on YouTube. These teaching, well, these workout classes, not the teaching classes. I want to put the teaching classes on Zoom, on YouTube. So I want you to be disciplined, be diligent, play the video, bring up the questions, work the questions before looking at the solutions. You have to master this topic because we're coming off it now. And it's a topic that is repeated a lot on the papers, as you can see. They don't really change the way that they set them much. And so you want to make sure that these questions that keep repeating, you get them right, fully right. And so you need to master them. Don't take them for granted. Master them. All right. I'm going to end it now. Okay, so bye.
Bye, Dad.
Bye, sir.
All right, bye-bye. See you next class. Bye-bye.